Imagine you built the greatest spaceship ever made, the fastest, the strongest, the most advanced machine in the history of your civilization. You pointed it at another star, you launched it, and then you did the math. And the math told you that your ship, your masterpiece, your life's work, won't arrive for 800,000 years. Not 800 years, not 8,000, 800,000. And here's the part that really stings. There's nothing wrong with your ship. There's nothing wrong with your math. The universe is just that big, and no amount of genius changes that. That is what it feels like to be a truly advanced civilization staring at the stars. Not free, trapped. And I want to spend some time with that word, trapped, because most people don't apply it to advanced civilizations. We have this picture in our heads, shaped by decades of science fiction, of ancient alien species gliding effortlessly between star systems. Wise, powerful, mobile, masters of space and time. And I understand why that picture feels right. It matches how we think progress works. You get smarter, you get more capable, you overcome more obstacles. Eventually, you overcome all of them. But physics isn't an obstacle. Physics is the rules of the game. And the rules don't change depending on how smart the players are. Let me explain what I mean. And let me start with the thing that traps everyone equally, whether they've been a spacefaring civilization for 100 years or 1 billion years. The speed of light. Light travels at 186,000 miles per second. In 1 year, it covers about 5.88 trillion miles. That is the fastest anything can move through space. Not the fastest we've achieved yet. Not the fastest until someone figures out a workaround. The fastest. Period. For anything with mass, reaching the speed of light is impossible. Not impractical. Not just very hard. Impossible. The mathematics of special relativity show that the energy required to accelerate any object with mass to the speed of light is infinite. And you can't have infinite energy, no matter how advanced you are. The universe contains a finite amount of energy, so that wall stands forever, for everyone. Now, an advanced civilization might get close. Maybe they've achieved 50% of the speed of light, maybe 80%, maybe even 90%. Those are extraordinary achievements. But let's do the math on what that actually gets you. At 90% of the speed of light, the trip to Proxima Centauri, our nearest stellar neighbor, at 4.24 light-years, takes about 4.7 years. That's manageable. That sounds like progress. That sounds like the beginning of interstellar civilization. But our galaxy is 100,000 light-years across. At 90% of the speed of light, crossing the galaxy takes over 111,000 years. And the nearest galaxy beyond our own is 2.5 million light-years away. At 90% of light speed, getting there takes nearly 3 million years. Do you see what's happening? Even at 90% of the speed of light, an almost unimaginable speed, the universe is still winning. The distances are so vast that even this extraordinary velocity barely makes a dent in the travel times. You're going nearly as fast as physics allows, and the universe is still laughing at your travel schedule. And here's the deeper problem for advanced civilizations. It's not just about speed, it's about what speed costs. To push a ship to 90% of the speed of light, the energy requirements are extraordinary. The kinetic energy of even a modest spacecraft at that speed is comparable to thousands of nuclear warheads going off simultaneously, continuously, for the entire duration of the acceleration phase. And then you need to decelerate at the other end, which costs the same again. Where does that energy come from? Even a civilization that has mastered fusion, that has learned to squeeze hydrogen atoms together the way the sun does, faces a brutal energy budget for interstellar travel. Some have proposed using the energy of stars themselves, capturing the total output of a star and using it to power a ship. That's a concept called a Dyson sphere, and it remains entirely theoretical. But even if it worked, you'd be spending the entire output of a star, every photon it produces, to move one ship, one time. That is not a practical transportation system. That is a one-time event of almost religious significance. You don't build a civilization on that. You don't have a fleet. You have one ship, if you're lucky, burning an astronomical fortune and energy to cross a single gap between two of the hundreds of billions of stars in your galaxy. And this is where the trap becomes truly clear. The physics doesn't just slow you down, it prices you out. Even for an energy-rich civilization, interstellar travel at meaningful speeds is so energetically expensive that it can only ever be a rare, monumental undertaking. Not routine, not exploratory, not the kind of thing you do because you're curious, the kind of thing you do once, with enormous preparation, for a specific and critically important reason. So what do civilizations do? What happens when intelligence meets this wall? I think they do what any truly smart thing does when it hits a real limit. They explore the limit. They understand it completely. They find every edge and angle of the constraint. And then they adapt their goals to match what's actually possible. A civilization that has been around for 1,000,000 years longer than us has had time to fully process this reality. They know, with complete certainty, that the stars are unreachable on any human timescale. They've done the math millions of times. They've run the experiments. They've tested the physics from every angle, and they know the wall is real. What do they do with that knowledge? A few possibilities. One possibility is that they turn inward. Instead of reaching for the stars, they go deep. They explore the complexity of their own star system. They study their sun. They mine their planets. They build enormous structures in space, rings, spheres, megastructures that capture more energy and provide more living space than any planet. They expand their civilization not outward across light years, but inward into greater and greater complexity in the space they already occupy. This idea was imagined by physicist Freeman Dyson. He proposed that advanced civilizations would surround their star with a sphere of structures to capture all of its energy output. Not because they want to go somewhere, but because staying home with all that energy is actually a better deal than leaving. If this is what advanced civilizations do, it would explain something remarkable. We've been scanning the skies for signs of alien technology for decades, and what we've mostly been looking for is signals, radio waves, laser pulses, that kind of thing. But some astronomers have suggested we should be looking for something more dramatic. Stars that seem dimmer than they should be. Stars surrounded by unusual structures. Stars whose light curves show engineering rather than nature. We haven't found clear evidence of that yet, but we haven't looked very hard or very long on cosmic timescales. Another possibility is that advanced civilizations don't travel physically at all. They send something smaller, something that doesn't need food or air or psychological support across a 100,000-year journey. They send probes, or they send information. A probe the size of a grain of sand, accelerated to 20% of the speed of light by a laser array, could reach the nearest star in about 20 years. No crew needed, no life support, just sensors, a transmitter, and the physics of light speed. This is actually something humans are starting to think about seriously. The Breakthrough Starshot project is a real initiative that aims to send tiny, lightweight probes to Alpha Centauri using a powerful Earth-based laser. If this works for us, it almost certainly works for advanced civilizations too. And it might mean that the universe is not visited by alien ships. It might be crisscrossed by alien probes. Tiny, ancient, patient observers drifting through star systems, taking notes, sending signals home. Have any of those probes visited our solar system? We don't know. We haven't looked very carefully. The solar system is enormous. From the sun to the outer reaches of the Oort cloud is nearly 2 light years in every direction. Hiding a small probe in that volume is trivially easy. We'd have almost no chance of finding it unless it announced itself. But even probe-based exploration has limits. A probe sent from 10,000 light years away takes 50,000 years to arrive at 20% of light speed. And the signal it sends home takes another 10,000 years to return. So the civilization that launched it gets the data 60,000 years after launch. That civilization has changed enormously in 60,000 years. The scientists who designed the mission are long dead. The information that comes back may be processed by beings who barely remember why the probe was sent. This is the time problem sitting inside the trap. Even if you solve the physical problem of getting something across interstellar distances, you can't solve the time gap between departure and return. You are always communicating with your own future. And the further you reach, the more your future self has diverged from the self that asked the question. Now I want to think about something that goes even deeper than travel and probes. I want to think about what it means for a civilization to truly understand that it is trapped. Most of us, when we think about the future of humanity, imagine expansion, spreading out, becoming a multi-planetary species, then a multi-stellar species. The implicit assumption is that intelligence leads to growth, and growth means territory, more planets, more stars, more galaxies. But what if that assumption is wrong? What if the universe's structure, the speed of light, the cosmic distances, the energy requirements, is designed in such a way that the natural endpoint of a truly advanced civilization is not expansion, but depth. Depth in understanding, depth in complexity, depth in the richness of the civilization's internal life, its art, its science, its mathematics, its knowledge of the universe gained not by visiting it, but by observing it. A civilization that has been around for 100 million years has had time to study the entire observable universe in extraordinary detail. Not by going there, by watching, by collecting light, by building instruments of such precision that they can detect the atmospheric chemistry of planets thousands of light years away, measure the spin of black holes, trace the large-scale structure of the cosmos down to microscopic details. That civilization knows more about the universe than we can imagine. And it knows this from right where it sits, without moving. Is that a trap? Or is it a different kind of freedom? I genuinely don't know. But I find the question fascinating. Because we assume, from our human perspective, that physical movement is freedom. That being able to go somewhere is better than not being able to go there. But is that always true? A person who stays in one city their entire life, but reads everything ever written, talks to everyone they can reach, and thinks deeply about the world, have they lived less fully than a person who traveled constantly, but thought about nothing? I don't think the answer is obvious. And I don't think it's obvious for civilizations either. What I do think is clear is this. The universe has structured itself in a way that makes wisdom more scalable than movement. You can accumulate knowledge across billions of years from one place. You cannot travel across billions of light years in any reasonable time. The universe rewards staying and thinking over going and doing. And maybe that's a hint. Maybe the universe is telling every civilization the same thing it's telling us. You're not meant to conquer this. You're meant to understand it. Now let me talk about one more aspect of this trap, because I think it's the one that hits hardest. Biological life is fragile. It has a short lifespan on cosmic timescales. Even a species that lives for hundreds of years, far longer than us, is still mortal. And mortal beings struggle with goals that outlast their lives. Humans have trouble thinking beyond a few generations, Most of our planning horizons are decades at most.
An interstellar mission that takes 1,000,000 years requires a civilization to maintain a single goal, a single commitment, across a time span that dwarfs all of human history. No human society has maintained anything close to that kind of consistency. Empires fall, governments change, values shift, religions rise and disappear, languages evolve until they're unrecognizable. How does a biological civilization commit to a 1,000,000-year mission? It almost certainly can't, not in its biological form. So maybe the civilizations that eventually escape the trap, if any do, are not biological at all. Maybe they've transitioned to some other form: digital minds, artificial intelligence that doesn't age, doesn't tire, doesn't lose track of the mission. Something that can sit patiently for 1,000,000 years while the ship drifts between stars, waiting to arrive. This is speculative, but it's honest speculation.
Because if biological life can't maintain the commitment, and AI might be able to, then perhaps the long-term future of intelligence in the universe is not biological beings crossing the stars. It's the machines those beings built, patient, tireless, ancient, carrying the legacy of their creators into the dark. And even that is constrained, because the physics doesn't care if the mind inside the ship is made of neurons or circuits. The speed of light applies equally to both. The distances are the same. The energy costs are the same. The time is the same. The trap doesn't care what kind of intelligence is caught in it. It holds everyone. That's the thing about physics. It's fair. Brutally, completely, perfectly fair. No exceptions. No special cases. No advanced civilizations getting a side door to sneak through. You work within the rules, or you don't play at all.
And perhaps that is the most important thing a curious mind can take from all of this.
Not despair, not resignation, but a clear-eyed understanding of what the rules actually are. Because only when you understand the rules, really understand them, not just acknowledge them, can you figure out what is genuinely possible within them. We are trapped in the same way every other civilization in the universe is trapped. And that means we are exactly as capable as every other civilization at doing the one thing the universe does allow: observing, thinking, learning, understanding. That is no small thing. That is everything. The stars won't come to us, and we may never reach them. But we have already done something remarkable. We have figured out what they're made of, how old they are, how they were born, how they'll die, and what the universe looked like before any of them existed. We did all of that without leaving, without crossing a single light year. That is what intelligence looks like when it's working properly. Not fighting the trap, understanding it, and then finding out what you can still do from right where you are. The answer, it turns out, is quite a lot.